This tutorial will help you to answer the questions on homework 16. The first section asks you to find the solution of the system of equations graphically, and we're going to graph our equations by using the y-intercept and the slope or rate of change value. So my first equation here has a y-intercept of -4, and it has a slope of 3, or 3/1. I'm going to put a denominator of 1 here so I know exactly how many units to rise and how many units to run. Right? So my rise is 1, 2, 3, and my run is 1. Rise 1, 2, 3, run 1. 3 up, 1 right. 3 up, 1 right. If I'd like to, I could even reverse that. Instead of +3, +1, +3, +1, I can do -3, -1. -3, -1. The more points you have, the straighter your line will be. Now, I can write the name of the equation here, y = 3x - 4, or if I'd like to, I can just label it here A as well as here. The second equation I'm going to label B, and I'll start graphing at +3. Now be careful, if your slope has a negative sign, remember you can only use it once. You can use it with the 1, or use it with the 2, but not both at the same time. So the first time, I'm going to use it with the 1. Down 1, right 2. Down 1, right 2. Down 1, right 2, down 1, right 2. And now I'm going to reverse it, up 1, left 2. Up 1, left 2, up 1, left 2, up 1, left 2, etc. Draw my straight line. Label my line on one of the edges here. And now it's time to find the solution. The solution is the point of intersection, which for us was +2, +2. Okay, let's take a look at question 2. Y = 3x - 4, and another matching y = 3x - 4. That means I have the same equation, so they have the same line that we're going to draw. Whoops, I'm supposed to draw that at -4 because it's a minus sign here. -4. The slope is 3, or 3/1, so that's up 3/1. 1, 2, 3/1. 1, 2, 3/1. 1, 2, 3/1. I'll reverse it. 1, 2, 3/1. 1, 2, 3/1. Try and make my straightest line possible here. And because I have two of the same graph, I'm not going to call them A and B because they're exactly the same. So I'll just write the name of the equation. Maybe I'll draw another overlapping line just to show that I have both there. And if all of your points intersect, then you have infinite solutions. Overlapping lines or coinciding lines have infinite solutions. Alright, let's take a look at this last one here. Sometimes kids get confused if they don't see a value here in the B position, right, or the y-intercept position. So y-intercepts can be invisible sometimes because if you write +0, which means nothing, you can leave it off in the equation, but you certainly can't leave it off in the graph. That has a y-intercept of 0. Has a rate of change of 2/1, 2/1, 2/1, up 2/1, or down 2 left 1, down 2 left 1. And now that I have my points, I'm going to draw my line here. Oops, a little curvy. Hopefully if you have a ruler you won't do that. I'm going to call that line A. And now I'm ready to graph line B, but unfortunately it's not written in slope-intercept form. So I'm going to have to do some rearranging here. I have to move that x to the other side, and when you switch sides, you switch signs. So now I'm ready to graph B here. This is function B. Has a y-intercept of +3, and has an invisible coefficient here of -1. So slope is down 1, right 1, down 1, right 1, down 1, right 1, all the way to the edge of the graph. The longer the line, the straighter I can make it. So remember, if you don't see the coefficient, it's an invisible 1. But if you don't see the constant, it's an invisible 0. So be careful. Looks like the point of intersection here is 1, 2. Don't forget to write the point of intersection. All right, let's move on to the second box. Tuesday box asks you to solve the equation and showing all steps. So it looks like my left side here is already simplified. There's nothing more I can do. But over here I can do some distributing. So let's rewrite our equation. And 1/4 times 1/3 is 1/12. And 1/3 times 6 is 1 times 6. And 3 times the invisible 1. So I'm going to rewrite this fraction here. 6/3 is the same as 2, or 2 over 1. So I'm going to write that as a 2. That'll make it a little bit easier when I go to subtract 3 from both sides. And I get 3/4 x equals 1/12 x minus 1. And then I'm going to subtract 1/12 x from both sides. And you can't subtract fractions that don't have common denominators, so I'm going to make this into 12. So then this becomes a 12 by timesing by 3. So this will have to be times by 3. And 9/12, take away 1/12 is 8/12. And I'm going to reduce this here. 8/12 can be reduced by dividing both by 4. And I can get 2/3. 2/3. And now to clear my final coefficient here, I'm going to multiply by the reciprocal. Multiply by the reciprocal. And there's my final answer. -3/2. Question number 5. This has two variables on the same side, so I'm going to combine like terms before I start using inverse operations. And now I can use some inverse operations here. Let's see. If I add 2c to both sides, it looks like my variable is going to cancel out. So when that happens, you have one of these special types of solutions. So I have a 9 left on the left and a 6 left on the right, and these two values can never be equal, so we call this not possible or no solution. There is no value of c that would satisfy this equation. Alright, let's move on to the Wednesday box. Asks us to state if an equation is linear or nonlinear. Now you are nonlinear if you have variables in the denominator, powers other than 2, or absolute value bars or square root signs, and products of variables. All of those disqualify you. So it looks like this one is nonlinear, and that's because it has absolute value bars around our variable. This one is going to be nonlinear because it has a power of 2. What else? Let's see. Do these break any rules? Powers? Nope. Variables in the denominator? Nope. Products of variables? Nope. Oh, this has a variable in the denominator, so this is nonlinear. And this one has a square root sign, so this one is nonlinear. And it looks like all the rest don't break any rules, so we would classify these as linear. So, variables in the denominator are nonlinear, powers are nonlinear, square root signs and absolute value signs, those are all nonlinear. Let's look at the final box here. To find the rate of change for the following data points, you would have to use your delta y over delta x formula, also known as y2 minus y1 over x2 minus x1. So that's going to give me -4 minus 1 over 3 minus 3, which is -5 over 0, which needs to be interpreted. Remember, a 0 in the denominator has to be interpreted, and the answer is undefined. You cannot divide by 0. Alright, identify the rate of change. Well, you can only do that by inspection, by using your eyeballs, if it's in slope-intercept form. So it looks like I'm going to have to do some rearranging here, or 2y equals 9x plus 6, and then getting my y by itself would give me y equals 9/2 x plus 3. So the rate of change is 9/2. Which of the following is not a linear equation? So we're looking for variables in the denominator, powers. Oh, there we have it. That breaks the rule. No variables in the denominator. All right, let's take a look at this last question. Is the graph shown to the right a function? Describe in words how you were able to determine your answer. Well, if looking at a graph, you can't have any inputs that repeat with different outputs, or your graph has to pass the vertical line test, right? Where if you were to draw vertical lines, you would never touch the graph more than once. So yes, this graph represents a function because, I'm going to abbreviate that, it passes the vertical line test. Now you can't just say it passes the line test or it passes the straight line test. You have to say that it's a vertical line because that's what's testing for repeating x values. And that concludes the video.